Hi everyone, so let's have now the graphs of polynomial function in Desmos. So normally on the basic math in high school, we need to know how to graph some functions such as linear, quadratic, and cubic. So let's have it here using Desmos. In this video, we'll focus on graphing in these functions such as linear functions with a degree of 1, quadratic function, a function with degree of 2, and then cubic functions with a degree of 3. Okay, this is how we're going to graph functions in Desmos. So let's open now desmos.com. So let me log in with my account. So I'm going to log in with Google, working with my account there. So it's much easier for me to save my work. So if I were you, make an account there so you can save your work. So I'm using my email now. It's already logged in. So now let me go with graphing calculator. So when we graph now polynomial functions, so we started with a linear function. So linear function has a degree of 1. So let's have it here. So now normally we saw it like f of x be equal to, right? So for example, you have now ax is the slider. We will discuss the slider, and then let's say it's, and then a is a slider. So when we say a slider, it is movable. So as you can see, you can have it this way. That's why it's positive and then going to negative. That's why when you have a slider, that's how it works. That's for the slope. Now, when we add now another slider, so there have now a limit from 10 to. So when we move this one, it goes to the left, and then when we move it to going to negative, it moves going there. As you can see, that's how you graph now a a linear function when there's a slider. Now, if you have a definite, okay, let's have now another one. So let me just say this linear function. Okay. So I save that. So how about if it's definite? So I make a new graph so that you would see. So technically you have now f of x be equal to, let's say the slope is 4 and then the y-intercept is 3. As you can see, it's on, when you look at it, here I'm zooming in, I'm zooming out. So you can see it's now a negative 3 as the y-intercept and the slope is 4. So 1, 2, 3, 4, and then 1 because it's over 1. Let's have another linear equation. So you can use y as well. Y is equal to 2x minus 3. And once again, that's how it works. And minus 5 rather. So it's in 5. So you can see that on the link. Now, another way when you have now a graph is that on a standard form. So you have now 2x plus 3y is equal to 1. So as you can see, this is now the intercept. It could be seen there. You can click the points and the points of intersection as well when you're graphing. Alright, so there's another way on how you graph the linear. We have now, for example, on the general form. So we have now 2x plus 5y minus 3 is equal to 0. As you can see, that's the violet line. So that's how you graph now the linear functions. Okay, now let's have this one. Let's go with quadratic. So when you say quadratic, it's the degree is 2. So if you have now f of x equal to, let's say we have now the vertex form so that we could have a slider. So ax minus h plus k. So let's say you have a slider for the leading coefficient, a slider for the x coordinate of the vertex, and then a slider for the y coordinate of the vertex. So as you can see, this is how it works. I forgot. It should be on the square to make it now quadratic. Now, when you move this one so that we will see now the behavior of the y is going up and then going down. Now, when you can see if this is everything is in 0, this one. Okay, we're able to see that. So the h will move the vertex. And now, if this is working, as you can see, let me just have it there in this way so that you would see. If you have now this one, you will see if it's positive, it's upward and then downward, right? So that's how you manage now your quadratic if you want to have a slider, but you could work that out. Okay, so let me just save this one, quadratic with sliders. Okay, now let's have now another. So how about if you want to graph now a definite function? So for example, f of x. So using the vertex form, so we have now 2x plus 4 squared and then minus 5. So that's now the graph of that. That's a vertex form. Now how about if I want to graph it in a standard form? So f of x be equal to negative 2x squared plus 5x minus 7. So you can see the graph is there, it's downward. We're able to see that. Or you can make it in another way. So y, the basic one, y raised to 2, that is now x squared. So we can have it that in manner. Okay, so that's how you work on the graph of a quadratic function. Okay, now let's graph now another function, which is a cubic function. So it's in the third degree. So let me just work that out on the graph of a definite quadratic function. So let's have now y is equal to x cubed. So as you can see, that is now how the graph looks like. So let me just have it. So it works like that. So let's have now another cubic function. So y is equal to x cubed minus 1. So if there's a constant, it goes down or up. Okay, another would be y is equal to negative x cubed, so that you will see the other one. And then plus, we'll add now another function, which is 2x. So you can see the curve turns out to be different. Then let's have another one. Let's have now adding a different variable as well inside a cubic function. Another degree of variable rather. So how about if we add a leading coefficient? We're able to see that. Then minus 5x squared. We're able to see the graph. And then let's have now a 4 cubic function, which is y is equal to 6x cubed minus 2x squared rather, plus 5x minus 1. We're able to see that. It's some kind of like a line, it's a block one. Okay, when you work that out, if we make this you can edit this one on the time so that those are different graphs as we could work out with your cubic. Okay, cubic functions. Hope you can explore more on Desmos. So once again, thank you for watching graphs of polynomial functions in Desmos. Thank you.